Alright, so it's time to do our Unit 7 review, and this will probably just be part 1. We have two functions, f and g, and we are supposed to perform the operations, and we are not going to find the domain. So number 1 says to take f of x times g of x, so that means we need to do this math right here. Come on. Just not writing very well, sorry. Alright, so that's the math we need to do there. You might recognize that as being a double, kind of maybe triple distribution problem, whatever you want to call it. So that would give us 2x cubed plus 12x squared and a minus 32x. And then when I come through and do these, that's 5x squared plus 30x, and then 5 times negative 16, I want to say that that's going to be negative 80. So now I combine like terms, if there are any. 2x cubed does not have a like term, but 12x squared and 5x squared makes 17x squared. 32, minus 32 and plus 30, those make negative 2x, and the minus 80 just comes along, and that's your final answer there. Number 2, we need to find f of 2, which just means take the number 2 and put it in place of the x on the f function. So that's just going to be 2 times x plus 5, and so we just fill in the 2 right there, and that gives me 4 plus 5, which is 9. Done. Number 3, we need to find f of x minus g of x, so that's going to be 2x plus 5 minus there we go. So here's kind of a one tricky thing. This side over here has got an x squared. This side doesn't. So I need to let that minus sort of multiply the x squared there. So that's actually going to be a negative x squared as my leading term. Then I'm looking at 2x minus a 6x. 2 minus 6 is negative 4. And finally, this 5 minus a negative 16, so 5 minus negative becomes 5 plus, so 5 plus 16 is 21. And I believe that is my final answer. Careful with those. Okay, number 4, we have h of g of 14, so we have 3 functions here. F, they're a little bit out of order. There's f, there's h, and there's g. So we need to take this 14 and put it into the x of the g function. So first I'm going to find g of 14. It's the inside part. So that's going to be the square root of 14 plus 2 and then minus 1. That comes out to be the square root of 16 minus 1. Remember that minus 1 is not under the square root, so that's just essentially 4 minus 1 is 3. Your calculator could have given you that. Here we go, and let's see. Now I take the number 3 and I put it into the h function. So h of 3 means I need to do 3 times 3 squared plus 2 times 3 minus 5. So that's 27. 6 and minus 5, that should come out to be a final answer of 28. Number 5, we need to do f h of negative 2, so that means we start by doing h of negative 2. We need to be careful using parentheses on this one. We need to use parentheses, because squaring negatives is tricky business. So that's what I need. Let's see, that becomes 3 times 4, that's 12. Your calculator could pretty much do this for you, no problem. Just type it in exactly the way it looks. 12 minus 4 minus 5 is 12 minus 9, that's 3. Okay, so now I f the 3. Put the 3 into the f function. So that's going to be negative 3 plus 4. Now I added those parentheses. I now see there's really no reason to have them, so it's just negative 3 plus 4, and that comes out to be a final answer of positive 1. 6, 7, and 8 are just more like algebra versions of 4 and 5, so here we go. So number 6 says we need to stick the g function into the f function. Well, the f function is negative 2x plus 7, right? So that x is going to get replaced with the g function, which looks like this. And now you would do the distributive property. And add the 7, and we get a final answer of this. There you go. Okay, looking at number 7, we have g of f of x. That means we need to stick the f function inside the g function. So let's get our g function going. Let's see. It's going to be something squared plus, and then it just says plus x, so that's just something right there, and then minus 6, so that's the g function. Now I'm going to put the f function into it. Alright, so right away, just so you know, that would be like partial credit on a test. We have a long ways to go still to get that done as far as simplified, so here we go. The front part of this is squared. That means there's really, we have to like do double distribution with this thing, so I'm going to list it out like this. It's not as easy as you want it to be, probably. And then we still have all this stuff as well. So we need to do the distributive property, that sort of thing. So it'd be 4x squared minus 14x, and then another minus 14x, and then a 7 times 7 is 49. And then this stuff back here, these parentheses aren't really doing anything because there's no number in front, so I'm just going to drop the parentheses. So it'll be minus 2x plus 7, and then a minus 6. Now we just need to combine like terms. The 4x squared does not have anything to combine with, but the 14x, and this 2x, they do combine. Negative 14 minus 2 is negative 30. And then there is a 49 and a 7 and a 6 that go together. 49 plus 7 minus 6, that's 50. Positive 50, and that's your final answer right there. So that's one of the longer algebra problems on the test. Number 8, we are supposed to do f of x plus 4, so the emphasis there is on the f function, which is negative 2 times x plus 7, so that really means we're going to fill in this x with the term x plus 4. So that's what we need to fill in right there. That's really just a distribution problem. So negative 2 times x and negative 2 times 4. So that gives us negative 2x minus 8 and then a plus 7. Notice that I did not distribute the negative 2 all the way over to the 7 because the 7 was not in parentheses. And finishing this up, we have a couple like terms. That negative 8 plus 7 makes a minus 1. And that is the end of that problem. Number 9, 10, and 11, our job is to find the inverse of the function. So basically we just need to write the reverse of the function, and kind of what we did in class is we would say this really means y equals 2x minus 3, and the inverse takes place when you switch the x's and the y's. So I just switch the x's and y's, and now we solve for y doing whatever it takes. Well, since there's a minus 3, I would add 3 to over here, so that gives me x plus 3 equals 2y, and then if I divide by 2, I get y by itself, which is pretty much my answer. Let me clean that answer up a little bit. So let's see, need some more room. So I would declare my final answer to be x plus 3 over 2, and then I could put y in front, or I'm going to put the fancy symbols for inverse, and that's my final answer right there. If you look back at the original problem said that we need to take x, multiply it by 2, and subtract 3. So the reverse order of that is to take x, add 3, and then divide by 2, which is exactly what we've got down there. Number 10, a little bit more complicated, but you know, if you see the x, what happens to it is there's a minus 1 involved, and then there's a squared, and then a plus 2. So we just need to like reverse the order of that, and you know, do the opposite thing. So since the last thing was to add 2, we're going to have to do a minus 2. Anyway, let me do a traditional way here, sorry. So y equals x minus 1 squared plus 2. Reverse the x's and y's. And now start solving for y. Again, the last thing comes first. So I would start by subtracting 2. So that's x minus 2 equals, and then this stuff is still in parentheses being squared, and so we need to get it out of there, so we square root both sides. So that gives me the square root of x minus 2 equals y minus 1. Technically there's a plus or minus that would go in front of that, because we just well, actually no, I'm thinking about that, I'm not really sure. Let's not focus on that for a second. And then we would add 1, and that would give me square root of x minus 2 plus 1. I just changed my mind. I think I do want that plus or minus in front. And that equals y. That's pretty much our answer right there. If I just kind of clean this up a little bit, that would be the inverse function of x is equal to the square root of x minus 2 plus 1. It's pretty much your final answer. Don't worry too much about it, but the plus or minus, I believe, goes in front of it. It's kind of a tricky issue. Number 11, a little bit quicker here. Change our Alright, so switch your x's and y's. And now try to get y by itself. So I would start by squaring both sides. So that gives me x squared equals y plus 3. And now I would minus 3. And I'm pretty much done. The answer is x squared minus 3. So cleaning up my answer a little bit, the inverse function is equal to x squared minus 3. Alright, that's the end of that.